Let's move on to question 5. It says complete Lewis diagrams and some physical properties for compounds are given. So again, let's go through and analyze this. It says based on Vesper theory, predict the geometry around the Si atom. 4 atoms and no lone pairs. My goodness, that is tetrahedral at its finest. Simple enough. A student claims that compound Y has a higher boiling point than compound X because compound Y has stronger London dispersion forces. Do you agree or disagree? If I look at these molecules, they all share similar intermolecular forces. You've got a similar structure, really. The only difference here in the structure is the carbon and the silicon. And so the answer to this is going to be yes. These share similar intermolecular forces. The only difference is that silicon is a larger molecule, and so therefore we would say that compound Y has a larger polarizable electron cloud. And so therefore would have stronger London dispersion forces and as a result have a higher boiling point. Easy way to check this is that silicon has a larger molar mass, it's a larger molecule, it has more electrons, so therefore has a larger polarizable electron cloud and greater London dispersion forces. So I would wholeheartedly agree with that statement. An equimolar mixture of the two compounds is heated. When the mixture reaches 82 degrees Celsius, which compound will have the higher vapor pressure? So higher vapor pressure just implies that there's going to be more molecules of gas of that particular compound at that temperature. Because compound X has a boiling point at 82 degrees Celsius, that tells me that this is going to be more readily become a gas at 82 degrees Celsius, and therefore would have more gas at 82 degrees Celsius. And so as a result, because it's going to have more molecules of gas, it will exert the higher vapor pressure. So we're going to say compound X for the aforementioned reasons that it boils at 82 degrees Celsius. And because it boils at 82 degrees Celsius, it will more readily become a gas than compound Y. And as a result, have more gas molecules and have a higher vapor pressure. The mixture is heated to 198 degrees Celsius in a sealed, rigid 12.5 liter container, at which point both gases and the total pressure is 2.3. Calculate the number of moles of gas particles. So this is just a straight up PV equals nRT question. So we're given our pressure, so 2.30. Our volume, which is given as 12.5 liters. We're going to solve for moles. R value, 0.08206. And our temperature needs to be converted to Kelvin, so we're going to take 198 plus 273.15, and that gives us 471.15. So now we just need to algebraically solve for moles. So 2.3 times 12.5 divided by 0.08206 divided by 471.15. That gives us our mole value of 0.744 moles of gas. And just like that, I believe we have finished question number 5. Yes, we're getting towards the end here. Kind of sad. This is always an exciting day for me, but we'll move on to question number 6. So if you're done, have a good day. If not, let's move on to 6.